New Horizons Pluto System Encounter. The closest approach of the New Horizons spacecraft to Pluto occurred at 11:49 UTC on July 14, 2015, at a range of 12,472 kilometers, 7,750 miles, from the surface and 13,658 kilometers, 8,487 miles, from the center of Pluto. Telemetry data confirming a successful flyby and a healthy spacecraft were received on Earth from the vicinity of the Pluto system on July 15, 2015, 0:52 and 37 seconds UTC, after 22 hours of planned radio silence due to the spacecraft being pointed toward the Pluto system. Mission managers estimated a 1 in 10,000 chance that debris could have destroyed it during the flyby, preventing it from sending data to Earth. The first details of the encounter were received the next day, but the download of the complete dataset through the 2 kilobits per second data downlink took just over 15 months, and analysis of the data will take longer. Objectives. The mission's science objectives are grouped in 3 distinct priorities. The primary objectives are required, the secondary objectives are expected to be met but are not demanded. The tertiary objectives are desired. These objectives may be attempted, though they may be skipped in favor of the above objectives. An objective to measure any magnetic field of Pluto was dropped. A magnetometer instrument could not be implemented within a reasonable mass budgeting schedule, and SWAP and PEPSI could do an indirect job detecting some magnetic field around Pluto. Primary objectives, required. Characterize the global geology and morphology of Pluto and Charon. Map chemical compositions of Pluto and Charon surfaces. Characterize the neutral, non-ionized, atmosphere of Pluto and its escape rate. Secondary objectives, expected. Characterize the time variability of Pluto's surface and atmosphere. Image select Pluto and Charon areas in stereo. Map the terminators, day/night border, of Pluto and Charon with high resolution. Map the chemical compositions of select Pluto and Charon areas with high resolution. Characterize Pluto's ionosphere, upper layer of the atmosphere, and its interaction with the solar wind. Search for neutral species such as molecular hydrogen, hydrocarbons, hydrogen cyanide and other nitriles in the atmosphere. Search for any Charon atmosphere. Determine bolometric bond albedos for Pluto and Charon. Map surface temperatures of Pluto and Charon. Map any additional surfaces of outermost moons, Nix, Hydra, Kerberos, and Styx. Tertiary objectives, desired. Characterize the energetic particle environment at Pluto and Charon. Refine bulk parameters, radii, masses, and orbits of Pluto and Charon. Search for additional moons and any rings. Flyby details. New Horizons passed within 12,500 kilometers, 7,800 miles, of Pluto, with its closest approach on July 14, 2015, at 11:50 UTC. New Horizons had a relative velocity of 13.78 kilometers per second, 49,600 kilometers per hour, 30,800 miles per hour, at its closest approach, and came as close as 28,800 kilometers, 17,900 miles, to Charon. Starting 3.2 days before the closest approach, long-range imaging included the mapping of Pluto and Charon to 40 kilometers, 25 miles, resolution. This is half the rotation period of the Pluto-Charon system and allowed imaging of all sides of both bodies. Close-range imaging was repeated twice per day in order to search for surface changes caused by localized snowfall or surface cryovolcanism. Because of Pluto's tilt, a portion of the northern hemisphere would be in shadow at all times. During the flyby, engineers expected LORRI to be able to obtain select images with resolution as high as 50 meters per pixel, 160 feet/px, If closest distance were around 12,500 kilometers, NVIC was expected to obtain 4-color global dayside maps at 1.6 kilometers, 1 mile, resolution. LORRI and NVIC attempted to overlap their respective coverage areas to form stereo pairs. LESA obtained hyperspectral near-infrared maps at 7 km/px, 4.3 miles/px, globally and 0.6 km/px, 0.37 miles/px, for selected areas. Meanwhile, ALICE characterized the atmosphere, both by emissions of atmospheric molecules, airglow, and by dimming of background stars as they pass behind Pluto, occultation. During and after closest approach, SWAP and PEPSI sampled the high atmosphere and its effects on the solar wind. VBSDC searched for dust, inferring meteoroid collision rates and any invisible rings. REX performed active and passive radio science. The communications dish on Earth measured the disappearance and reappearance of the radio occultation signal as the probe flew by behind Pluto. The results resolved Pluto's diameter, by their timing, and atmospheric density and composition, by their weakening and strengthening pattern. ALICE can perform similar occultations, using sunlight instead of radio beacons. Previous missions had the spacecraft transmit through the atmosphere, to Earth, downlink. Pluto's mass and mass distribution were evaluated by the gravitational tug on the spacecraft. As the spacecraft speeds up and slows down, the radio signal exhibited a Doppler shift. The Doppler shift was measured by comparison with the ultra-stable oscillator in the communications electronics. Reflected sunlight from Charon allowed some imaging observations of the night side. Backlighting by the sun gave an opportunity to highlight any rings or atmospheric hazes. REX performed radiometry of the night side. Satellite observations. New Horizons' best spatial resolution of the small satellites is 330 meters per pixel, 1080 feet/px, at NICS, 780 meters/px, 2560 feet/px, at Hydra, and approximately 1.8 kilometers/px, 1.1 miles/px, at Kerberos and Styx. Estimates for the diameters of these bodies are: NICS at 54 times 41 times 36 kilometers, 34 times 25 times 22 miles, Hydra at 43 times 33 kilometers, 27 times 21 miles, Kerberos at 12 times 4.5 kilometers, 7.5 times 2.8 miles, and Styx at 7 times 5 kilometers, 4.3 times 3.1 miles. This translates to a resolution of 164/124/109, 55/42/7/3/ and 4/3/ pixels in width for NICS, Hydra, Kerberos, and Styx, respectively. Initial predictions envisioned Kerberos as a relatively large and massive object whose dark surface led to it having a faint reflection. This proved to be wrong as images obtained by New Horizons on July 14 and sent back to Earth in October 2015 revealed an object just 8 kilometers, 5.0 miles, across with a highly reflective surface suggesting the presence of relatively clean water ice.